Hello, I am Dr. R. Muthukumaraswamy, Professor and Head, Department of Applied Mathematics, Sri Venkateswara College of Engineering. I am going to discuss today one-dimensional heat equation using Crank-Nicholson scheme. You know the general form of one-dimensional heat equation, A dou U by dou T equal to dou square U by dou X square. Okay, now in this case, I am going to use the finite difference scheme, finite difference solution of the equation. So dou U by dou T is nothing but, instead of using the dummy variable T, I am going to take Y. So finite difference scheme for dou U by dou T, first partial derivative Uij plus 1 minus Uij divided by K equal to Ui plus 1j plus Ui minus 1j minus 2Uij divided by h square. Okay, I'll call it as this one, equation 1. Now take the same equation, we'll go for another equivalent formula in the left hand side. Instead of doing this is forward formula, we'll take a backward formula for the dou U by dou T. So Ui j minus Ui j minus 1 divided by K equal to, so there is no changes in this right hand side as it is. Okay, yeah, it will be equation 2. Now, so what Crank-Nicholson idea is, so I'm going to change equation 2 similar to equation 1 in left hand side. So how I'm going to change? So what is the difference between these two suffix? I is fixed, only the changes in j. So I'm going to just modify this particular equation 2, that is using backward formula only. This is using forward formula and this one using backward formula. Now replace j by j plus 1 in equation 2. Now you see, after swap, changing the suffix j to j plus 1 in this equation throughout, Ui j plus 1 minus, when I replace j by j plus 1 minus 1 is nothing but j only. So Uij by k, right hand side Ui plus 1 j plus 1 plus Ui minus 1 j plus 1 minus 2Ui j plus 1 divided by h square. Let it be, this is equation 3. Now equation 1 and 3 are almost left hand side is identical. Now what to do? I'm going to add these two equations. By adding equations 1 and 2, I'll get 2 times of a Ui j plus 1 minus Uij divided by k, and right hand side my denominators are identical, so I'll take h square of Ui plus 1j plus Ui minus 1j minus 2Uij plus Ui plus 1j plus 1 plus Ui minus 1j plus 1 minus 2Ui j plus 1. Of course here also h square. Now I'm going to cross multiply, so therefore I can rewrite Ui j plus 1 minus Uij equal to k divided by 2a h square. So cross multiply, followed by Ui plus 1j plus Ui minus 1j minus 2Uij plus Ui plus 1j plus 1 plus Ui minus 1j plus 1 minus 2Uij plus 1. So I'm going to take this entire thing in a different combination of a constant as what we have done in the Bender-Schmidt scheme. So lambda is set to k divided by a h square. Of course a is a constant, k is the step size along time direction, h is the step size along x direction. By setting this proportionality constant, modifying this way lambda, j plus 1 equal to uij plus lambda divided by 2 times ui plus 1j plus ui minus 1j minus 2uij plus ui plus 1j plus 1 plus ui minus 1j plus 1 minus 2uij plus 1. Okay, now I am going to combine uij and these two terms, that is these two equal to, so you'll get 1 minus lambda times uij. Hope you are able to understand. Lambda by 2 multiplied by minus 2 is nothing but minus lambda, so these two are combined. The remaining thing I'm going to take straight away. Lambda by 2 ui plus 1j plus ui minus 1j plus ui plus 1j plus 1 plus ui minus 1j plus 1. Now see the last term I am going to club with left hand side. So when I multiply lambda by 2 into minus 2, you will get minus lambda. If I take this term to the left hand side, you will get 1 plus lambda ui j plus 1. So in this equation, okay, I'll call it as this equation number 4. Now, what is our ultimate aim is to dilute the coefficient to 0. That is, we have to dilute the entire uij to 0. Therefore, I am going to choose 1 minus lambda equal to 0. I am going to dilute this coefficient to 0. Therefore, lambda equal to 1. If I substitute lambda equal to 1 in this equation, you will get 2 times ui j plus 1 equal to 1 by 2 times u I plus 1j plus u I minus 1j plus u I plus 1j plus 1 plus u I minus 1j plus 1. By dividing this constant to the other side, we will get a Crank-Nicholson formula. 1/4 of u I plus 1j u I minus 1j u I plus 1j plus 1 plus u I minus 1 j plus 1. So this is what the Crank-Nicholson formula. So this particular scheme valid only if 0 less than lambda less than or equal to 1. So that is the speciality of the Crank-Nicholson method. The method of finding out all unknown values at advanced time level using known values at a given time level is called implicit method. Of course, Crank-Nicholson is an implicit method. Now see the time levels here given. Ui minus 1j is a nodal point. Of course, this is uij. Ui plus 1j, that is forward direction. This is backward direction. So this is given time level. The next time level, the nodal points are ui minus 1, or one step along time direction, j plus 1, ui plus 1j, one step along j plus 1. So now in this method, we are going to take lambda equal to k by ah square. We have already discussed in the book work. By setting lambda equal to 1, that is what the Crank-Nicholson scheme. So when I set lambda equal to 1, k equal to ah square. The finite difference scheme you can easily recall by using this molecular structure of the diagram. Uij plus 1. I want to find out this value is nothing but average value of these four. It's very simple. Just take this particular level, forward and backward values, same way the next level, forward and backward values. Just taking average value of these four is nothing but our Crank-Nicholson scheme. So this particular scheme is unconditionally stable. Now we are going to solve a numerical problem. So dou u by dou t, dou square u by dou x square, 0 less than x less than 1, time positive, with u of 0 comma t, u of 1 comma t 0, u of x comma 0 equal to 100 times x into 1 minus x. This is some function is given to you. Compute u for first time step. So from the statement itself, it's very clear any problem, if you want to attempt for only one time step, you go by Crank-Nicholson. Suppose the problem you want to solve more than, that is more 5 times steps, then we prefer Bender-Schmidt scheme. So that these two are key words in the statement of the problem. Sometimes the method is given to you, otherwise you can easily identify. If it is single time step, you go by Crank-Nicholson. Okay, here, so what is our constant? A equal to 1. And you know very well, according to Crank-Nicholson, we have discussed already, k equal to a h square. Since a equal to 1, the k value is h square. The material length 0 to 1. So the choice is left to you. You can choose the step size according to your choice. But what is the better choice? We are going to solve system of equation. That is what the outcome of implicit model. So this is 0.25. 0.5, 0.75. So I am going to take the step size 0.25. So therefore, k equal to 1 by 4 whole square. So which is nothing but 1 by 16. Okay. Now, you know very well the Crank-Nicholson scheme, uij plus 1, 1/4 of ui plus 1j plus ui minus 1j plus ui plus 1 j plus 1 plus ui minus 1 j plus 1. Okay, here the implicit model. Now I'm going to take time step. So you can go by simple diagram for better understanding. So this is time step 0. The next time level, okay, t equal to 1 by 16. Take a simple diagram. So this particular point x equal to 0. Of course, this is 0.25. This is 0.5, 0.75, and this end is 1. Okay. So at time t equal to 0 is already given. Okay. This particular condition. Now give x equal to 0 here. The numerical value for this particular temperature is 0. Yeah. Similarly, give 0.25. That is 0.25 means x equal to 1 by 4. If I give x equal to 1 by 4 here, you will get a numerical value 18.75. And the next, give x equal to 1 by 2. In this condition, boundary condition, you will get the numerical value 25. Similarly, you set 0.75, 18.7. And the other extreme value, x equal to 1, the numerical value 0. So our focus only on the given time level, the numerical data. This is only an x value for your reference. Okay. Now I want to calculate the next level values. That is what our aim. Now these two sides, the boundary conditions are set to 0. Why? Because that's given at x equal to 0, throughout 0 for any time level. Yes. And x equal to 1 for any time level, the value 0. Yes, I know. But what is the speciality of in this model? Both the extreme sides are 0, and very interesting thing, these two are duplicated. So I want to find out these three unknown values. So what is implicit method? I've already mentioned. I want to find out more number of unknown values, whereas in explicit method I want to find out only one unknown value. That's a basic difference. Values I want to find out, so it preserves symmetry. Therefore these two values are duplicated. It's almost like paper folding. I think this is the center A, B, A. I want to find out the unknown value A equal to, so you know the finite difference scheme, the average value of these four constants. So 1/4 of 0 plus B plus 25 plus 0. I skip zeros, so you will get B plus 25. Let it be equation 1. Now take B midpoint. That's what we have done already. A plus 18.75 plus 18.75 Therefore 1/4 of a plus a 2a plus 18.75 plus 18.75, so which is nothing but 37.5. Equation 1 and 2. Now substitute equation 1 in equation 2. So b equal to 1/4 of 2 times a, that is 1/4 of b plus 25 plus 37.5. So b equal to, on simplification, I think we can proceed further. So 1/4 of b divided by 2 plus 12.5. Of course, you know it's very simple calculation, plus 37.5. So this implies, so b 1 minus 1 by 8 equal to 50. So therefore b equal to 14.2857. So now substituting a in equation b, you will get b value 14.2857. From equation 1, substitute b value, yes, you will get a. If I know a and b, then I can find out the final answer at a given time level 1 by 16. This is prescribed condition u of 0 comma t equal to u of 1 comma t equal to 0. Since it preserves symmetry, 0.25 comma t as well as 0.75 comma t, the numerical value 9.8214, and then u of 0.5 comma t equal to 14.2857. Now solve. Dou square u by dou x square equal to 16 times dou u by dou t, 0 less than x less than 1, time positive. With u of x comma 0, u of 0 comma t 0, u of 1 comma t 100 times t. Compute u for 1 time step. Here a equal to 16, t equal to h square. You know how to calculate. You will get the value 1. Choose step size 1 by, that is what I use. So you know the Crank-Nicholson formula. Let us take the time step t equal to 0 and t equal to 1. Now here the boundary conditions entirely different. Entire base level x equal to 0, 0.25, 0.5, 0.75 is the material length 0 to 1. I am taking step size. All this entire value is given 0, and this side t equal to 0 is by default 100 into 0, 0. If I give t equal to 1, this side extreme value 100. So I am going to use this finite difference scheme. At a, I am going to take average value of these 4 nodes 0, b, 0, 0. So 0 plus b plus 0 plus 0 is nothing but a equal to 1 by 4 times of b, the equation 1. At b, average value of a, c, 0, 0. So a plus c divided by 4. At c equal to 1/4 of b plus 100, equation 3. Now take equation 1 and 3, substitute in the middle equation. Why? Because a in terms of b, c in terms of b. If I substitute, you will get b equal to 1/4 of a plus c. So b by 4 plus 100. So I am dividing separately. On simplification, you will get the numerical value b as 7.1429. From equation 1, a equal to, that I rewrite the equation again, a equal to 1/4 of b. I know the value of b, yes, I am substituting, I will get the numerical value a. From equation 3, c equal to 1 by 4, b plus 100. So I am substituting b value 7.1429. You will get the numerical value of c 26.7857. So therefore the final answer, these two are given already in the problem. U of 0.25 comma t 1.7857, u of 0.5 comma t equal to 7.1429, and u of 0.75 comma t 26.7857. Okay, that's the end of the problem. Thank you.